Kia ora Year 12 and Year 11. This question is question 10 from the June 2021 AS paper, and that's from paper 13 or 1-3, and it's really a coordinate geometry and a little bit of geometry question. So we start off where we've got 3 points, A, B and C, that lie on the circumference of a circle with centre D. First, we have to show that angle ABC is 90 degrees. Now, I don't know about you, but I just can't visualize that without drawing a graph. So you should always draw an accurate sketch in a question like this. You're going to use it the whole way through. First, we have to find that angle, and then we have to find the coordinates of the center of the circle. And from there, we have to get an equation of the circle. So I'm going to go to a new screen and draw a rough but decent sketch. Okay, so I'm not doing this in GeoGebra on purpose because I know that when you're in the exam, you won't have GeoGebra. So it's not going to be perfect, but you can see that we've got -2 there roughly, and we've got 3, we'll put 3 in about there, and then 6 is about out here. So that's enough to get me, let's roughly do the y-axis now. So we've got -2, 3 here, 3, 0 here, and 6, 5 we'll put about up there. Okay, so it doesn't have to be a perfect sketch. Let's see what we had to do. Right, the first thing we have to do is to show that angle ABC is equal to 90 degrees. So a couple of things come to mind. The first thing, and not the fastest thing I don't think, is to say, well, if A, B and C have an angle of 90 degrees, then Pythagoras must hold. So we could look at the length of AB, and we could look at the length of BC, and we could look at the length of AC. And we could, from there, figure out that this one squared plus this one squared is equal to this one squared, right? And you can work through that, but the much cleaner way is to say that if 2 line segments are perpendicular, then their gradients multiply to give -1, right? So if perpendicular, then we have the gradient between A and B times the gradient between B and C must equal -1. So what's A? Well, A is -2, 3, B is 3, 0, and C is 6, 5. So the slope between A and B is equal to the change in y over the change in x. We can go with whichever one of those we want. So we'll do 3 take away 0 over -2 minus 3, which gives me -3/5. And now we do the same thing with B and C. So the gradient between B and C, this time we're going to go this one take away this one, so it's going to be 5/3. And we have to show that it's a right angle, so we need to do some reasonably careful working for this. So -3/5 times 5/3, which equals -1. Therefore, AB is perpendicular to BC. And if AB is perpendicular to BC, angle ABC is equal to 90 degrees. Now, you can go and do the Pythagoras way yourself. It's not heaps more work, but it is going to get you some pretty messy numbers. You end up with the length of AB is √34, and so on. So you will get there. It's just, I think, a slightly less efficient method. Let's look at part B. So part B says we have to find the equation of the circle. So again, my graph is really going to help me. Now, we know that all 3 of those points are on the circle, and we know that this angle is 90 degrees. We also know that the angle in a semicircle is 90 degrees. So this AC line must be a diameter, right? It must be going like this. Now, this is going to be a really bad drawing. Let's see how it goes. There, we know that we have to have that situation. And so the center of my circle, D, must be the midpoint of AC. So how am I going to write that down? Well, angle in semicircle is 90 degrees. Therefore, AC is a diameter. Don't know what's happening with this pen today. I think it's the Wellington heatwave happening. So D is the midpoint. And the midpoint is -2 plus 6 over 2, 3 plus 5 over 2, which gives me the coordinates of D are 2, 4. And we can have a look with our good graph and see if that looks about right. And you can see that it does. Remember that point there is 3. And so this point up here is 2, 4. Right, so that looks pretty perfect to me. Okay, question C is to find the equation of the circle. So for this we need the radius. Now we've got C is 6, 5 and D is 2, 4. So CD, the length CD, is going to equal the change in the x coordinates squared. It's just Pythagoras, right? So 6 minus 2 squared plus 5 minus 4 all squared, which gives me the square root of 17. And that means that my circle equation for C, well, I need to have the centre of the circle. So it's going to be x minus 2 squared plus y minus 4 squared is equal to the radius squared, which is 17. And that's as far as you need to take that one. So remember, what I'm using there is that if we've got a circle with centre x naught, y naught, and radius of r, then the equation of the circle is this. Okay, right, now on to D. The point E lies on the circumference of the circle such that BE is a diameter. Find an equation of the tangent to the circle at E. So the first thing that we need to do is that we need to find the coordinates of point E. So let's go back to our bad graph. And I'm going to magically erase some of this stuff here. I'm going to leave point D on there, and I'm going to take all the other stuff off. So I'm leaving D on there because we know that D is the centre of the circle. And BE is a diameter. Right, so if BE is a diameter, then taking this ruler, we know that we have to go back up here to this point. Let's get a really thick blob there. So we've got BD, and then we want to keep on extending back by the same distance. So where is point E? Well, E is going to have x coordinate that's moved back 1 again. So to get from B up to D, we went back 1 and up 4. So we're going to do the same thing again to get up to point E. So E is equal to 3, take away 1, take away 1. And the y value is going up by 4 each time. So 0 and then up 4 to get back to the centre, and up 4 again to get up to here. So point E has coordinates 3 minus 2, which is 1, 8. Okay, so I'm going to draw that circle in really badly now to see what we've got with the tangent coming in. Okay, not too bad. I think good enough that you can see what's going on. Right, so we'll take our ruler and we're trying to find the equation of the tangent there. So what I need to know is the gradient of that tangent line. Now, if you're doing this and you're doing A-level, you're probably thinking that you're going to use implicit differentiation to do this, and you could do that, but you don't really need that. All you need to notice is that the gradient from B to E is, just by looking at it, well, we've gone down 8, so it's -8, and we've gone out 2. So the gradient from B to E is -4. And that means the gradient of the tangent line will be perpendicular to that, right? Because the gradient is perpendicular, the tangent is perpendicular to the radius. Okay, so at the tangent, the gradient is perpendicular to the radius. So the tangent gradient is equal to 1/4 because the BE gradient was -4. That means that the equation of my tangent is going to be a straight line with a gradient of 1/4. And we know that it goes through 0.18, so it's going to have this equation, y is equal to, so 8 is equal to 1/4 times 1 plus c. So c is equal to 8 minus 1/4. Not a very nice number, but there you go. So you get 31/4. So a couple of ways to write this tangent line. The first way is just like that. The other way that you might want to write it is to times everything through by 4. So 4y is equal to x plus 31. And sometimes you'll see it written with 0 on one side. So x minus 4y plus 31. So any of those equations is just fine. Thanks for watching. I'm going to get question 11 done shortly, and that will wrap up the Pure 1 paper from June last year.